Okay, so this is actually based on some ideas and some work I actually did a number of years ago. Never really did anything with it because it wasn't actually very easy to do back then. But I've got access to some infrastructure that makes it a little easy this time. So the basic idea is there's this public exchange, this peering fabric. This is where a number of routers may be connected to an Equinix or switching data or D6 or any other of the dozens of exchanges. And what we want to try to do is figure out who's peering with who on the public exchange fabric. And so what you have to do, and it's not anything that's not obvious, but you get behind the network that you want to figure out who has peering relationships with others and do trace routes. And if you can trace route to one of the public peering addresses and get a response, you can presume that they're peered. And so, of course, you have to go find out all these address blocks that the exchange uses, and you have to somehow get behind all these networks to build this graph. So one easy way to do that is to use the peering DB. There's a list of approaching 200 exchanges in there, and there's at least 125 prefixes that you can get them, which are mostly 24s, but there's some /19s and some 25s and some smallers. And then you get a number of remote hosts, which may be easier for some than others. I have access to a number of machines around the net on different providers. And as well as there's a nice toolkit that you can use, the script route, which is essentially kind of based on the Planet Lab infrastructure. And you just launch Ruby-based tools and commands, and they have everything all pre-built for doing traceroute. And you essentially launch your traceroute using any of the servers that are part of the script route network. So you can get behind those networks, or at least a great deal of them. And then you get your traceroute output, and then you start parsing through that and then see who's actually peered. So I did that, and I just used Speakeasy because that was one of the first ones I wanted to graph for this talk. And so I discovered that at the 5 major Equinix locations, this is what their peering graph looks like. So they're the center, and all the nodes at the edges are people they're peered with. Now, the work that I did is maybe not exact. I wasn't real rigorous in doing this, so if someone from Speakeasy is looking at this and sees that the numbers are slightly off, that may be, I may missed some here and there. And in fact, one of the things I discovered right away is that there was 5 that they were at the Equinix exchanges here in North America. They list 4 on their peering page, and they list 4 on the peering DB. Those 2 sets of 4 are not congruent. So this is maybe a nice way to actually kind of verify your configuration or someone else's configuration if you're trying to find out where people are at and who they're peering with. So then you can go further and you can do an entire exchange peering graph. So if you can get behind enough networks, you can actually start to build up to see who really peers with who. And depending if you can get behind enough networks and launch enough trace routes and do the analysis, you could build something like this. This is a sample. This is not everyone at the Equinix Ashburn, but it's sort of a subset of some networks and who they're connected to, and some fairly significant ones like AT&T and Hurricane and some others. And so maybe the obvious question is then, is this something that we should be able to do? Is this a good thing? Is it a bad thing? Is how is this possible? Why can you actually do this? So people, in my experience and just looking at this sort of tangentially, is that the networks who are at these exchanges at least tend to advertise those exchange net blocks within their own network, so internally. So if you're behind with those networks, you can get to those public addresses at the exchange. A few do seem to announce them publicly and to customers or peers for some reason. I don't know exactly why this is. My guess is that maybe default configuration of a reduced connected, perhaps. I actually inquired one of the networks this afternoon about why they do that, and I got sort of an odd answer. I'm not clear on why, but apparently they said it was as a service to their customers, and I don't know why any customers would want to see the public address space, but that was their answer. I think they didn't really have a lot of time to actually want to spend on this, and I don't blame them. So do we care about this? I don't know. This is maybe just sort of interesting, but is it necessarily a bad thing? I don't know. Maybe it's not so much, but it opens up some possibilities for something maybe interesting to people to work on. Maybe it makes some certain attacks more possible, or enable some. I'm almost done. Can you wait 1 second?
Sure.
So it maybe enables some sorts of attacks, maybe geographic-based attacks. So in North America, this may not be such an issue because we have lots of exchanges and lots of places, but maybe for smaller markets, this may be an issue. Some people may be concerned about enumeration or privacy issues. Obviously, this might be neat for researchers to actually understand topology better. Maybe certain exchange operators may want to do market research, maybe not necessarily on their own exchanges, but to see how they compare to other exchanges. And maybe they would hire someone to do surveys of this, like this. You may even be able to figure out where you actually want to go and peer at based on building these sorts of maps. And then lastly, something Danny McPherson pointed out to me, I sort of just made it in time for the slides, is this may enable easier stealing of transit if you can get. If someone is actually advertising this public address space either globally or from within their network, maybe to set up a tunnel and actually use that facility to actually use that to actually transit through those pairing addresses, not having to use your own. And so just real quick, I'd be interested if anyone actually thinks this is sort of worthwhile, or I should spend any more time on this, or if this is enough, this is, or if you'd want to see like the Dwayne Wessels kind of maps on this sort of thing, and maybe animations about how peering evolves over time. Just maybe quick show of hands. Is this sort of interesting? Maybe someone want me to, or have someone actually do more of these maps or graphs? Is this any value? Not so much? Okay. Someone have a question over here?
Hi, Louis Lee, Equinix. I've spoken with some of our customers about why they're announcing the exchange subnet, and one answer, which I have accepted from them, is that they announce only to their transit customers to facilitate a trace route that the customer might do, so it doesn't look like that there's some kind of bad stuff going on at the exchange interface, so that their trace route packet would get back to them.
Okay, thank you.
This is derived from recommendations in about February 1997 at NANOG.
I missed the first part. Can you say it again?
Randy Bush, IJ. What Louis just described is specifically from recommendations made by out of a group of backbone operators for how to operate at an exchange point, which is to announce the exchange point fabric down, not to peers.
Okay. And is it maybe also used for monitoring too, I imagine?
Yeah.
People being able to monitor their own stuff. So.
I mean, your network and your customers want to see that, but you don't want to announce it to peers. They should be announcing it to their customers.
Sure. Some people do seem to announce it globally in certain cases, and certain exchanges seem to be better about it than others. So. But thanks. Okay, thank you.